Hey, what's going on, guys? Let's do this problem right here. So let's see how we can find out whether this series converges or diverges using ratio test for series. So usually this one is used to find whether some series is absolutely convergent. So first let's get the idea how to find this one. So here what the condition is, when we take limit n approaches infinity and we take the absolute value of an plus 1 over an, and if this value is less than 1, if let's say the value we are getting is L, and if this value is less than 1, this is convergent, and if it's more than 1, this is divergent, and if it's equal to 1, there's no conclusion, so we have to find out another way to do it. So let's see whether we can find some of this, right? So here what we are going to do, we are going to take the, so first, we are going to directly take that limit. So limit, in the numerator we have an plus 1. So this means that wherever we have n, we just add 1. So in this case, we have n square right here. So this is going to be n plus 1 square. And in the denominator we have 2 power n. So this is going to become 2 power n plus 1. Then we divide this one by original function. So this is going to be divided by n square. So we divide this one by n square over 2 power n, right? So instead of writing like this, what we can do, dividing by this one is same as multiplying by 2 power n over n square. Because when you divide, this is going to flip around and goes to the top. So instead of dividing, you can write like this. So this way it's much easier, right? So here you can say that 2 power n plus 1 is same as 2 power n multiplied by 2 power 1. So you can cancel this 2 power n with this one. So you are going to have 2 power 1 remaining. 2 power 1 is remaining. And then we have n power 1 square over n square. So let's simplify this one. So here we're going to have, so this is absolute value we are taking, right? Limit n approaches infinity, and then we are going to have n plus 1 square, and if you expand this one, this is going to be n square plus 2n plus 1, and in the denominator we are going to have 2 power 1. So instead of writing 2 power 1, I can bring it to the front. So this is going to be 1 over 2 right here, and then we have n square absolute value, and you can see the numerator and denominator have same power, so the coefficient is going to be the limit. So here you can see this one, you can say this one is same as 1 n square. If we don't have anything, this is simply 1, right? So this is going to be, the ratio is going to be 1 over 1. So it only works if you have same power. So the limit is going to be just 1. And 1 multiplied by half right here. 1 times half. So that's going to be half. So here the half is less than 1, right? So this is less than 1. So we know that if it's less than 1, this is a convergent series. So we can conclude this is a convergent series. Convergent. So this is a convergent series. And that's how we do the ratio test. I hope you guys find this video helpful. See you next time.